watch the video at least to make up the notes. Alright, so tell me what you know about secant and cosecant. Don't be shy for the camera. You know nothing? Shout something out. What do you know? It is the inverse or not the opposite, the reciprocal. Okay, so when I'm looking at secant, that is, if I graphed secant x, it is 1 over cosine x. So when I put that in my graphing calculator, you can't type in secant, you have to graph in, or type in 1 over cosine. This is going to have asymptotes, because it's a fraction, right? When do we have asymptotes on a fraction? When the bottom is 0. So the asymptotes are going to be where it's undefined, or where cosine of x equals 0. On the unit circle, the spots for cosine are 0 are the top and the bottom, which are pi halves, right? And 3 pi halves. Hopefully that will make sense with what you see on the graph. And this is similar to tangent and cotangent, that what we do is we kind of figure out where the asymptotes are first. So I'm going to type in 1 over cosine x. I'm going to make my window negative 2 pi to 2 pi, scale of pi halves. And I'll make my y min negative 4 and my y max 4. And always, for graphing, we have to just double check that we're in reading mode. Okay. So these are kind of U-shaped graphs. They repeat. They have all these extrema, like this is a minimum, this is a maximum. How high or low, I guess, does it look like this minimum is? 1. And it is. Here's why. The cosine at 0 is 1, and what's the reciprocal of 1? 1. So when you're making your u's, you're going to have them rest at 1 and negative 1. So let's sketch a picture of the graph. And I'm going to do, I'll go negative pi, and then this would be negative pi halves, positive pi halves, positive pi, 3 pi halves, 2 pi, and why don't I just go back the other way? By the way, sometimes I'll say cosine of x, sometimes I'll say cosine of theta. You can use those interchangeably. They mean the same thing, they're a variable. Okay, so remember we said that the asymptotes of this graph were at pi halves and 3 pi halves, and that should sound familiar because they are the same as what other function that we studied yesterday? Tangent. Okay, so get your asymptotes on there, and I'm going to make this 1 and negative 1. And then we just make our u's. Over here, it's only half of it. I mean, I can continue the graph, but it's going to continue on to another asymptote at 5 pi halves. Okay, So it takes just how many cycles then for it to repeat? Or how many radians? 2 pi. Same as what? Cosine. Let's write that down. The period is 2 pi. And the asymptotes in general are x equals pi halves plus k times pi, where k is an integer. Another way of describing that is odd multiples of pi halves. Because they would be at 1 pi halves, 3 pi halves, another one at 5 pi halves, and so on.